Dana doesn't pay her taxes. Dana doesn't what? Dana doesn't pay her taxes. Yeah, how do you think she's so smart? She's actually making millions of dollars. What?
So this is the last thing we're doing before we start practicing for the takeover quiz. So we've done all things you'll be expected to put on the graph. I give you. We've done vertical asymptotes, we've done horizontal asymptotes. It's been a while, so we'll review them for sure. But now we've done where's the function increasing, decreasing, where's their turnaround points, like relative max, relative min. And today we're getting into the curve of it. So is it going to curve up and be concave up, or curve down and be concave down? And then where does it switch from one to the other? And between all of those things, you can very accurately make a graph just using calculus and not using your calculator. So that's what we're heading towards. So concave up is, it looks like a U, like it's curving up, it looks like a U, so you get that. But really, it's either, it doesn't have to be connected, it's either that or that. You get like these two possibilities. So this function would be concave up and decreasing. This would be concave up and increasing. Concave down looks like the N. So again, it could be the increasing part or the decreasing part. If you put them together, it would look like that. So tomorrow we'll go through and analyze like these four shapes. Basically, every graph is either a line or one of these four shapes. Like isn't sine and cosine just that over and over and over? But it was going to be those over and over again. Okay. So if a function is concave up, like a parabola, what is f prime doing? So these are concave up, and it's easier to see on the increasing part. So if I take the slope, like what's the slope right there? It's 0. Now it's some positive number, right? Like as I slide to the right, now it's some positive number. So what happened when I went from here to here to the slope? It increased and got bigger. And then if I go like up here, isn't it going to be an even bigger positive number? So increasing. And it's happening over here too. It's just harder to tell because we're going down. But the slope here might be like -8, let's say. It's a steep negative. When I get to around there, maybe it's -1. And then when I get to here, it's 0. So aren't those slopes increasing also? I know it's negative, but 0 is bigger than -1, which is bigger than -8. So f prime, concave up, that means f prime is increasing. Or the slope of f is increasing. Because what's true about the slope of f and f prime? They're the same thing. So I can say that either way. So f prime is increasing, or the slope of f is increasing. Or you could say f is curving up. I know they just asked this one. What is f prime doing? But I'm just trying to say it different ways. If a function is concave up, then f prime, that's what we just did. Okay, so if a function is concave up, then f prime is increasing. If a function is concave down, then f prime is decreasing. That was weird. Like 5 seconds ago, I was like, "Will should walk in." It's like programmed in my brain, like when you're gonna walk in. So f prime greater than 0, f double prime greater than 0. So this is like the last. If your second derivative is positive, that means f is concave up. So you'll get either that or that. If your second derivative is negative, that means I should write out the word, I guess. Since we talked about it the first time about 5 seconds ago, probably should abbreviate it. And then so if the second derivative is negative, that means the function's concave down, which is one of those two shapes, or both, but oh yeah, thank you. Is that part okay? Like what is concavity? Is that a good question I can answer on that? We're doing alright? Alright, thank you. Like your faces either look like it's Tuesday and it's a 3-day weekend and this sucks. Or I don't have a clue what you're talking about. I couldn't tell which was which. Sine of x. So eyeballing where it changes, where the function changes concavity can be kind of tough. I'm try to. So this one is pretty clearly like a U up until around there. Would you agree? And then that's what's called a point of inflection, where the concavity switches. Yeah, so I was going to try to like color code it here. So that's concave up because we're making a U. And then it changes there. And then it goes back to making a U. And then it changes to making an N. And that's probably curving back up here. It is because it's sine, so it's going to curve back up there again. So the points of inflection are where it's the graph switches from curving upwards to curving downwards. So you see how that graph is it's just U's and upside down U's, like linked together. And where they switch from a U to an upside down U is the point of inflection. So these are. So what's up?
The green is concave down, right?
The green is concave down. And the red's concave up. Good?
I just wanted to check.
Yeah, totally. So this is the original function. We're concave up here. What does that mean is true about the second derivative in this red area? It's positive. Second derivative is positive. Now we're concave down, so the second derivative is negative. What's the second derivative right there at that point of inflection? 0. So remember how in like increasing and decreasing to find a relative max and relative min, we take the derivative and set it equal to 0? So the top and bottom equal to 0. We're doing the exact same thing, but just at the second derivative level. So we're doing the same process, we're just going to use the second derivative to do it instead of the first derivative. So let's do this one algebraically. Can I erase that graphing part? With my arrows and colors. It was beautiful. It's time to move on. Alright, so let's find the concavity for this function. So they're not asking me increasing, decreasing, so I don't really care about the first derivative. I only need the first derivative to get to the second, but I'm not going to like work with it. So y prime is x to the third minus 12x plus 1. And if I were asking you to find where the function were increasing, decreasing, relative max, relative min, those 4 things, you would set this equal to 0 and make your big table. But in this one I'm not. I'm just saying concavity. So we skip. Concavity comes from the second derivative level. So we skip right down to the second derivative. And I set the top and bottom of that equal to 0. So there's no bottom, right? But if there was, I would do that too. So set top and bottom equal to to 0. So there's no bottom, but 3x squared minus 12 equals 0. I can factor out a 3. And that's the difference of squares, so I can say plus 2 minus 2. And then remember, you set these 3 pieces equal to 0. So what happens when I set 3 equal to 0? That's never true, right? That will give me x equals negative 2. And that will give me x equals 2. So those are like my second derivative critical points. So far, so good? Crucial points. Can I erase that? Okay. We're good? Alright, so I'm going to make my chart, but I'm going to make it with the second derivative instead. So x, and then the sine of f double prime, and then what does that tell me about f? So I've got negative 2 and 2. So like negative infinity to negative 2, negative 2 to 2, 2 to infinity, and what was my second derivative was 3x plus 2x minus 2. This is like easier for me to plug into, so I'll use that one. So we want to know about concavity. Concavity comes from the second derivative level. So we're plugging back into the second derivative. So you get these 3 situations. So if you want to know the y value of a function, what do you plug into? The original. If you want to know if the function is increasing or decreasing, what do you plug into? The derivative. And if you want to know concave up and concave down, plug into the second. So those are the 3 things to keep track of. What level does relative max and relative min come from? First, because that goes with increasing and decreasing, right? Points of inflection go with concavity, so they'll come from the second derivative. So you're plugging back into the level that we care about. I'm looking for concavity here, so I'm plugging into the second derivative. So plug like negative 10 in here. That would make this negative. That would make this negative also. So this would actually be a positive there, which means in that interval, the graph is concave. At negative 2, what's the value or what's the sign of f double prime? 0, that's where we got it from in the first place. Same with this one. So it might be a point of inflection, it might not. It's a potential point of inflection. Negative 2, 2, let's say I plug in actual 0, positive, positive, negative, so that's a negative sign. So now we are concave down. And then 2 to infinity, let's say I plug in like 20, everything's positive then. So this is positive, and then this will be concave up. So the intervals of concavity, so we're concave up from negative infinity to negative 2, and 2 to infinity. If I justify it, I know that's true. F double prime is greater than 0 or positive, yeah. So f double prime is greater than 0, or you can write out positive. Concave down from negative 2 to 2. Just the opposite reason. Second derivative is negative. And then points of inflection. Bless you. So when we had this chart with like relative max, relative min, I cared about the order. So if the function were increasing and then decreasing, that makes a relative max, right? But opposite of that, if we were decreasing and then increasing, it makes a relative min. So relative max and min, I cared like which happened first. With point of inflection, I don't. If the second derivative changes sign, it's a point of inflection. So you don't have to worry about up to down or down to up. Point of inflections happen at x equals negative 2 and x equals 2. And yes, they both candidates were, but that's not always true. The reason for this is because f double prime of x changed signs. Hopefully that process feels familiar, right? You're just doing it on the second derivative instead of the first. Questions on that or anywhere? Any rates? Is everybody still right? Okay, so then let's look at graphs. These can get tricky. Because now we have three different graphs to keep track of. You gotta know how to answer questions. If I give you the original graph, if I give you the derivative graph, if I give you the second derivative graph. So this is f prime. I want to know the points of inflection and state the intervals of concavity. So I know this. I know that concave up means the second derivative is greater than 0. But I don't have a graph of the second derivative. So I only have a graph of the first derivative. So I have to like take this graph and go down a level, or take the derivative of this graph. How do I take the derivative of a graph? What do I look at? Slope. Good. So another way to say this is the slope of f prime of x is greater than 0. So like right here, the slope of this graph is greater than 0. That means the derivative of this graph is greater than 0. Well, this is already the derivative. So the derivative of this graph puts me where? Second derivative. If that's positive, we know we're concave up. So this graph is concave up between -1 and 1. And then between 2 and 3. And I already justified it. And you could use either one of those as justifications. That's tricky. Like, some of you might even look at it now and you're like, that's no big deal, I get that. When it comes back around, it's not like I'm doing this exact thing today. That's a hard thing to keep track of. So the biggest advice I can give you is you just really got to know that those two things are the same. The second derivative and the slope of the first derivative are the same thing. Concave down would just be the opposite, right? So I'm looking for the second derivative to be negative, which means the slope of f prime needs to be negative. So that happens between -4 and -1, and then 1 and 2. Please ask questions there. You have. Can I help with anything there? Over this again, explain this a different way. Alright, and then points of inflection just happen where we switch. So I want f double prime of x to switch signs. Or I want the slope of f prime to switch signs, because the second derivative and the slope of f prime are the same thing. So I want to know where the slope of this graph changes signs. So like, what's the slope right here? It's negative. Now we're positive, so isn't this a spot where they change signs? So that's going to be at -1. And we kind of knew that already. Like, if I was concave down up until -1 and then concave up after, then there was a switch there. That's what a point of inflection is. It happens again at x equals 1. Notice this too, is this function differentiable at that spot? It's not, because that's a cost per corner, whatever you want to say it. But it's still a point of inflection, even though it's not a spot I could take the derivative of. Then at x equals 2. Questions there? Number 3 is a second derivative. So again, realize what we're working with. What does the second derivative tell us? What does it tell us about? It tells us about concavity, right? So if the y values of that graph are positive, what do we know about the original function? Concave up. So I know that when f double prime of x is positive, f of x is concave up. That's a true statement. That's like the definition of concave up. And where does that happen on this graph? It's from negative infinity to negative 3 and 1 to 3. So this part here, the y values, which represent f double prime, are positive. When f double prime is positive, that means concave up. And then the opposite, I should have colored it. This should be blue, and all these should be blue. For the opposite, when the derivative is less than 0, that means that the original function is concave down. And that happens when we're below the axis. So from negative 1 to 1 and from 3 to infinity. It's probably very hard to tell if you understand these two graphs or not. Just like you just gotta do them to get to that point. So we'll do that soon. And then where are their points of inflection? On this graph, the points of inflection happen when the concavity changes. This is a graph. The y values on this graph represent concavity. So like right here, the original graph is concave up or down? Up. Down. So isn't that a point of inflection? And then that. So at x equals negative 3 and x equals 1. Oh, wait. And x equals 3. Questions? Let's do this. Do the graphs right now. I don't know if we'll get a number of this today. That's okay. I want you to try 8 through 13. So keep that in mind. Every graph you look at, you got 3 possibilities. It could be half, it could be half prime, it could be a double. I put up the answer to 8 if you want to see it, but you know, don't.
did the whole thing.
You found like concave up and down also. That's not gonna hurt you. I can put that up too for checking purposes.
Oh, I just put my
You guys seen? Has anybody seen Puss in Boots?
Yes. Oh my god, it's so good. It is so good. It's so good. Don't tell me it's bad. That makes
No,
sense.
I should say
It's
that's somewhere in there. They
so
call it.
cute.
Yeah, I fall asleep like that.
Oh, it's so good.
Somewhere in there, someone calls someone a fun. A little dog calls someone a fun.
The dog my favorite.
Oh my god, it swears too.
When it went up on that rant, that was hilarious.
So good. That movie's so good. Cinematic masterpiece.
It was so
Good. Your grandma has taste.
I hate number 9 is so stupid. I hate when they make it like
This one's like
Yeah, I was gonna say.
9 fits. Yeah, 1.8. That's what I. So it's here
Oh.
and then here, but that's not at. I mean, whatever. If you put 2, it does.
Yep, it says two.
That doesn't look like 2 to me.
it's not.
Look at it to me.
You're
right. Right. That's gross. Yeah. Roasted.
Because it doesn't change signs.
Don't say it. What doesn't change signs? Your face? I don't even know what you're talking about. What about it? What are you talking about? It doesn't change signs.
Continue multiplication.
Positive, negative,
Negative
positive.
1. For negative 1, it doesn't. So with negative 1 doesn't count as a point of inflection. Or is that just for
Negative 1 doesn't count as a point of inflection because f double prime doesn't change signs.
I know, but I didn't know if it just counted for like the algebra or if it counts on the graph too.
It does. I'm just saying f double prime is a is. Was the point I was trying to make.
You. You're one of them kids.
There's nobody can be an it pronoun in this one. What are your pronouns? It. Too bad.
Oh.
Are 8, 9, and 10 okay? Questions on 8, 9, and 10 before I go forward to 11, 12, and 13? Do it again for this one.
Yeah.
So there's 11, like with explanations. I'll put up 12 and 13. Not making sense, please let me know so I can hopefully help make it make sense. Maybe.
It's like your cards.
It's so stupid.
Oh my god.
It's so dumb. Dumb and
Yeah, I love
stupid.
It's
Twice.
doesn't jump high enough, it just goes. My god.
Okay, are 11, 12, and 13 okay? We're good there? Alright, let's go back to. I know some of you are doing the work, but I want to do number 4 in the video notes. Talk about are we above or below the graph? So remember the tangent line. If I have a concave up situation, looks like that. And I were to draw a tangent line anywhere, does that tangent line go above or below a concave up situation? It goes below. So when this is saying, like, does this line tangent line above or below, they're basically asking you to find the concavity. If it were concave down, well, then whenever I draw my line, wherever I draw it, I'm going to be above. So this is just like a fancier way to ask you, is the function concave up or concave down at that spot? So that's the original. What level do I need to be at to talk about concavity? Double prime. So I got to take the derivative of that, and the derivative of that again. So this is product rule with a little chain rule. So the derivative is, you guys learned fig plus gif, right? So fig is the derivative of the first thing, which is 1, times the second thing, so e to the negative x, plus gif. So this, yeah, g prime would be e to the negative x times negative 1. Like, don't forget that chain rule piece. And then times f, which is just x. Yeah, I felt like I was just rambling. That just kept saying words. I feel like questions on how I'm getting that derivative? So I don't have to simplify it, but it might make my life easier. Let me see if I can. So I have e to the negative x minus x times e to the negative x. So I could, if I wanted to, like combine that and make that e to the negative x times 1 minus x and do product rule with that. Or I could just start from here and do product rule. Okay, first person to talk gets this.
I like the
Second one? Okay. So if this is my y prime, I gotta take the derivative of that. So fig plus gif. So you take the derivative of the first thing. So what's the derivative of e to the negative x? E to the negative x times negative 1, or negative 1, yeah. Times just your second thing. So that's like my f prime. Fig is f prime g. So this is f prime and this is g. Gif is g prime f. So what's g prime? What's the derivative of that second piece? It's just negative 1. And then you're just writing down the first piece. Question on how I got that second derivative? Yeah.
Would we be able to use calculators for like derivatives and stuff for this unit?
It's this part of it's a take-home quiz, so you're gonna have your second part of that. I don't know. Yeah.
If this question was on the test.
This could very easily be on the non-calculator part. Is that how you're trying to get to it? I don't know. Yeah, it could be. Is there any benefit in simplifying this? My job is just to find out if this is positive or negative when x equals 1. So simplifying takes time. I might screw it up. I'm going to plug in 1 now before I screw it up. Although I still might. We'll see what happens. That's nice. Because what's 1 minus 1? All of that just goes away. And I get negative 1 over... I don't know why I didn't put 1 there. That's a 1. So I get negative 1 over e. E is a positive number. I don't care what that comes out to. I just care if it's positive or negative. So the second derivative is negative or positive? Negative, which means the original graph is concave down, which means my tangent line goes above. So when it says y, so we're going to say it goes above because the second derivative is negative. Questions on that? Which number are you guys starting to learn about?
6.
6? 6 is 1 whiny?
It's just a lot, and it's very silly. I didn't want to do it.
Pretty whiny.
Yeah.
Remember that I think it might be like less word. If you bring it up and use product, like that's an option.
Yeah, I think that's what they do.
So I don't know. I mean, that might make it shorter for you, or you might still think it's stupid. It's
No,
giving
it
you a
was
choice.
just like, the more I did it, I was like, wow, this is really funny. And then,
This is a very good question for me to put like on your take-home quiz because that has two asymptotes. So it makes you do a lot more with it. Where's their vertical asymptote in that question? X equals 1 because the bottom is 0 and the top is not. Where's their horizontal asymptote? It's not never. It's not never. So you're going to repeat it.
No, I know. Shit.
Well, there is one.
I do.
Sex on a roll.
Yeah, X, yeah.
What? How does it? How do you
Higher powers.
Oh,
Oh, I see.
Where's the higher power?
there is none. It's the same.
It's tied, so you take the coefficients of the higher power.
Oh, shit.
interesting.
Remember, if it was like this, interesting. I've never seen that before.
Oh, wow.
That's crazy.
Wow.
Where's the higher power here? Bottom. So then where's your horizontal asymptote? Higher power's in the bottom.
Zero. Infinity.
It's gonna be 0.
Okay. I was right the first.
Well, you weren't, because you were just like spamming answers.
Just say everything.
Where are the vertical asymptotes here? Asymptotes. So then what you'll get, just to like show you what's coming, I'll have a horizontal asymptote here. Vertical asymptotes at -1 and 1. And then you'll get like these shapes that go in the middle. And so I don't know what this looks like, but it could end up maybe something like this. And you just kind of build your shapes around your parameters. And
Wait, so
I don't know if that's it. That's where that's what we're trying to get to. So do what you can do on that assignment tomorrow. Bring it in. I fully expect we'll spend a good bit of the class just going over questions together. That's fine. And then I'll start showing you how the shapes piece together. Thursday I'll give you like a practice test. Friday I'll give you more practice in class and test to take them. Then I'll give it to you. So we have tomorrow to wrap this up and then 2 days of practice. And then I'll give it to you Friday and I'll give you Monday. Are you serious? Oh yeah, I know how many.
No, you're a little higher.
More than halfway.
well, we should be more than halfway because the test is in.
Considering that this semester is on Friday, I think it's pretty good.
But the test is before the end of the year.